Blind and visually impaired individuals frequently need to access visual information to navigate everyday scenarios effectively. These needs span a range of everyday scenarios, like identifying objects, reading texts, and describing surroundings. Traditional computer vision-based assistive tools have enabled more independent access to visual content for BVI users. Oftentimes, these tools use specialized models for specific visual tasks. For example, Seeing AI offers channels like short text for reading labels and currency recognition for identifying money. However, while these systems generate responses in real time, they often tend to offer generic feedback. Users must actively listen to all the information being read out and filter out the irrelevant bits until they finally reach what they need. Modern LLM-powered visual question answering apps, such as Be My AI, allows users to make personalized queries and generate targeted responses. However, these systems are not real-time and rely on individual, well-framed images that contain the relevant information. In practice, capturing such images without vision can be difficult and can require multiple rounds of trial and error. We present CustomSight, a hybrid computer vision and LLM-powered assistive tech that helps BVI users query visual information through task-aware, real-time guidance, which can capture image automatically when relevant content is in view. Let's consider a scenario where the user wants to learn about the sashimi options on a printed, non-accessible restaurant menu. However, since it is a multi-page menu, it may happen that the initial photo taken by the user does not contain the sashimi options. While a regular LLM-based system might respond asking the user to manually take a better picture, CustomSight instead tries to see if any on-device computer vision models can be utilized to automatically capture a more relevant picture. CustomSight creates a dynamic filter, which is a task-specific pipeline that monitors live video feed, uses relevant computer vision models, and triggers context-aware feedback to facilitate automatic image capture.
Sashimi options found. Sashimi options. Picture taken.
Behind the scenes, the generated dynamic filter starts an OCR model and continuously looks for relevant keywords associated with various kinds of sashimi. It also generates contextually relevant audio feedback and speech output to let the user know if the relevant information is in the frame, and automatically takes the picture as the user holds their device steady. Let's look at another example where the user is trying to learn about the cooking instructions of a canned food item.
Run. Button. Run. Cooking instructions. Start program. Button. Cooking instructions. Picture taken. AI is replying. Ellipsis. AI replied. The image clearly shows the cooking instructions for the black beans. For stovetop, empty contents into a saucepan.
These generated dynamic filters can be saved for future reuse and can also be shared with other users. This can enable users to directly capture relevant images for recurring tasks.
Picture taken. AI is replying. Ellipsis. AI replied. The humidifier remote is visible on the nightstand, near the head of the bed and next to a black fan.
In our current implementation, the dynamic filters can use text and object recognition models to perform keyword checks and pattern matches, providing feedback through speech and sonification. Our design is flexible and can be extended in the future to incorporate other computer vision models like depth estimation, as well as additional output channels such as haptic feedback to support a wider range of scenarios.